Paper, System Analysis and Design. Section A, Information System and Database, 50 marks. I Object Modeling, 25 marks. Question 1, differentiate between a class and a method. 5 marks, answer. Class. A class is a blueprint or a template that defines the structure, attributes, and behavior, methods, of objects. It's a conceptual definition and does not consume memory until an object is created from it. Think of it as the design plan for building a house. Method. A method, also known as a function or procedure within an object-oriented context, is a block of code associated with a class or an object. It defines the actions or behaviors that objects of that class can perform or the operations that can be performed on the object's data. Continuing the analogy, methods are like the actions you can perform with the house, such as open door or turn on lights. Question 2, what is the difference between public, private and protected access modifiers? 5 marks, answer. Access modifiers control the visibility and accessibility of classes, methods, and attributes within an object-oriented programming language. Public. Visibility, accessible from anywhere, both within the class itself and from outside the class, including other classes and packages. Purpose, used for members that form the public interface of a class, allowing other parts of the program to interact with the object. Private. Visibility, accessible only within the class where they are declared. They are not visible to any other class, not even subclasses. Purpose, used for data hiding and encapsulation. It restricts direct access to internal implementation details, ensuring that data can only be manipulated through the class's public methods. Protected. Visibility, accessible within the class where they are declared, by subclasses, derived classes, in the same or different packages, and by other classes within the same package. Purpose, used when a class wants to allow its subclasses to access certain members while preventing access from unrelated classes. It facilitates inheritance while maintaining a degree of encapsulation. Question 3, lists some characteristics of UML? 5 marks, answer. UML, Unified Modeling Language, is a standard general-purpose modeling language used in object-oriented software engineering. Key characteristics include 1. Standardization, it is an internationally recognized standard for modeling software systems, promoting common understanding and consistency. 2. Visual language, it provides a rich set of graphical notations and diagrams to visually represent different aspects of a system. 3. Object-oriented, it is specifically designed for object-oriented analysis and design, supporting concepts like classes, objects, inheritance, polymorphism, etc. 4. Generality/applicability, it is applicable to various types of systems, development processes, and programming languages, not limited to a specific domain or technology. 5. Extensibility, it allows for the creation of custom stereotypes, tagged values, and profiles to extend its capabilities for specific domains or technologies. 6. Independent of implementation language, UML models are conceptual and abstract. They are not tied to a specific programming language, making them useful for design before coding begins. 7. Iterative and incremental, it supports iterative and incremental development processes, allowing models to evolve and refine over time. Question 4, class diagrams are the most common diagrams used in UML. Explain for purpose of the class diagram. 5 marks, answer. Class diagrams are static structure diagrams in UML that depict the static structure of a system by showing its classes, their attributes, operations, or methods, and the relationships among classes. 4 purposes of class diagrams are: 1. Modeling the system structure, they provide a clear visual representation of the classes within a system, their internal structure, attributes and methods, and how they are interconnected. This helps in understanding the overall architecture. 2. Capturing business logic/domain model. Class diagrams can be used to model the conceptual classes in the problem domain model, helping to understand and communicate the business logic and key entities involved. 3. Designing database schemas. The classes and their relationships in a class diagram can be directly mapped to tables and relationships in a relational database schema, aiding in database design. 4. Forward and reverse engineering. Forward engineering, they serve as a blueprint for implementing the system in code, guiding developers on what classes, attributes, and methods to create. Reverse engineering, tools can generate class diagrams from existing code, helping to visualize and understand the structure of an existing system. Question 5. Give an example of a class, composed of a name, attributes and methods. 5 marks. Answer. Class name, book. Attributes, data members/properties. Title, string, the title of the book. Author, string, the author of the book. ISBN, string, the International Standard Book Number, unique identifier. Price, double, the price of the book. Is available, Boolean, indicates if the book is currently available. Methods, behaviors/operations. Book, string title, string author, string ISBN, double price. Constructor, initializes a new book object with the given details. Get title, getter, returns the title of the book. Get a user, getter, returns the author of the book. Set price, double new price. Setter, sets a new price for the book. Mark as borrowed, sets is available to false. Mark as returned, sets is available to true. Display book info, prints all the information about the book, title, author, ISBN, price, availability. 2. Database administration with MySQL, 25 marks. Question 1. Explain the following terms briefly: one-to-many relationship, many-to-many relationship, participation constraint, overlap constraint. 4 marks. Answer. One-to-many relationship, a relationship between two entities where one instance of the first entity can be associated with 0, 1, or many instances of the second entity, but an instance of the second entity can be associated with at most one instance of the first entity. Example, one department can have many employees, but an employee belongs to only one department. Many-to-many relationship, a relationship between two entities where one instance of the first entity can be associated with 0, 1, or many instances of the second entity, and vice versa. Example, a student can enroll in many courses, and a course can have many students enrolled. This usually requires a linking/associative table to resolve in a relational database. Participation constraint defines whether an entity instance is required to participate in a relationship. Total participation, mandatory. Every instance of an entity must participate in the relationship, represented by a double line in some notations. Partial participation, optional. An instance of an entity may or may not participate in the relationship, represented by a single line. Example, every order must have a customer. Total participation of order in places relationship, but a customer might not have any order. Partial participation of customer. Overlap constraint applies to generalization/specialization hierarchies. It specifies whether an instance of a superclass can belong to more than one subclass. Overlapping, an instance can belong to multiple subclasses simultaneously. Disjoint, non-overlapping. An instance can belong to only one subclass. Example, a person, superclass, can be both an employee and a student, overlapping, or a vehicle can be either a car or a truck, disjoint. Question 2. List and explain 4 advantages of using a DBMS, 3 marks. Answer. 4 advantages of using a database management system, DBMS, are: 1. Data redundancy control. A DBMS helps reduce and manage data duplication. Redundancy. By storing data in a centralized and organized manner, preventing inconsistencies and saving storage space. 2. Data consistency and integrity. By enforcing integrity constraints, example primary keys, foreign keys, validation rules, a DBMS ensures that the data stored in the database remains accurate, reliable, and consistent over time. 3. Data security. A DBMS provides robust security features, including user authentication, authorization mechanisms, granting specific permissions to users, and encryption, to protect sensitive data from unauthorized access or modification. 4. Data sharing and concurrency control. It allows multiple users and applications to access and modify the same data simultaneously without compromising data integrity. The DBMS handles concurrency issues, example using locking mechanisms, to prevent data corruption. 5. Backup and recovery. A DBMS provides utilities for backing up database content and recovering it in case of system failures, hardware malfunctions, or data corruption, ensuring data availability and business continuity. Question 3. Does the relational model, as seen by an SQL query writer, provide physical and logical data independence? Explain. 3 marks. Answer. Yes, the relational model, as seen by an SQL query writer, largely provides both physical and logical data independence. Independence. This means that the physical storage structure and access methods of the database can be changed without requiring changes to the logical structure or application programs, like SQL queries. SQL query writer. This implies they don't need to know how the data is physically stored on disk, example file organization, indexing, disk fragmentation. They just query the tables. If the database administrator changes the indexing strategy or moves data to a different storage device, the SQL query will still work without modification. Logical data independence. This means that changes to the logical schema, example adding a new column to a table, renaming a column, should ideally not require changes to existing application programs that do not use the changed data. For an SQL query writer, if a new column is added to a table, existing queries that don't select or filter on that new column will continue to function. If a view is used, changes to the underlying tables can sometimes be absorbed by redefining the view, thus insulating applications that query the view from logical schema changes. Question 4. Why does a DBMS interleave the actions of different transactions instead of executing transactions one after the other? 5 marks. Answer. A DBMS interleaves the actions of different transactions, executes them concurrently, instead of running them strictly one after another, serially, primarily for performance and efficiency. 1. Increased throughput. By interleaving, the DBMS can keep the CPU and I/O devices busy, even if one transaction is waiting for an I/O operation to complete. This maximizes the number of transactions processed per unit of time, leading to higher system throughput. 2. Reduced response time. Concurrent execution allows multiple users to feel like their requests are being processed immediately, as they don't have to wait for other long-running transactions to finish entirely. This improves the perceived response time for individual users. 3. Resource utilization. Many transactions involve I/O operations, reading from/writing to disk, which are relatively slow. During the time one transaction is waiting for an I/O operation, the CPU can be allocated to another transaction. This efficient utilization of resources, CPU, disk, leads to better overall system performance. 4. Scalability. Interleaving is crucial for database systems that support many concurrent users or applications. Serial execution would quickly become a bottleneck in such environments. While interleaving improves performance, the DBMS must also ensure that the concurrent execution is correct, i.e., serializable. This means the final state of the database after concurrent execution must be the same as if the transactions were executed serially in some order. This is achieved through concurrency control mechanisms like locking, timestamping, and multi-version concurrency control. The instance of the student's relation shown in figure above. A given example of an attribute, or set of attributes, that you can deduce is not a candidate key, based on this instance being legal? 5 marks, B. Is there any example of an attribute, or set of attributes, that you can deduce is a candidate key, based on this instance being legal? 5 marks. Answer. The student's relation instance is Sid name login age GPA 50,000 Dave at CS 19 3.3 53,666 Jones at CS 18 3.2 53,688 Smith at EE 19 3.8 53,650 Smith at Math 19 3.8 53,831 Madayan at Music 11 1.8 53,832 Goldu at Music 12 2.0 Export to Sheets. A candidate key is a minimal superkey. It uniquely identifies each tuple in a relation, and no proper subset of its attributes can uniquely identify tuples. A example of an attribute, or set of attributes, that you can deduce is not a candidate key. Name, Smith appears twice, for Sid 53,688 and 53,650. Therefore, name alone cannot uniquely identify a student. Age, multiple students have the same age, example 19 appears 3 times, 18 appears once, 11 and 12 appears once. GPA, multiple students have the same GPA, example 3.8 appears twice. Login, Jones at CS and Goldu at Music appear for different SIDs, but Smith at EE and Smith at Math appear for different SIDs, so login might seem unique in this instance, but generally logins are expected to be unique. However, if we look closer at Jones at CS, it belongs to 53,666 and Dave at CS belongs to 50,000. So, the email prefix part, example Dave, might not be unique if the domain is not unique, but the full login itself is unique in this given instance. Correction: upon closer inspection, all login values in the given instance are unique. Name, age. Smith, 19. Appears for Sid 53,688 and 53,650. This combination is not unique. Age. GPA. 19, 3.8. Appears for Sid 53,688 and 53,650. This combination is not unique. Conclusion for 5A, based on the given instance, name, age, GPA, name, age, GPA are examples of attributes or sets of attributes that are not candidate keys because they do not uniquely identify all tuples. Example of an attribute, or set of attributes, that you can deduce is a candidate key. SID, each SID value, 50,000, 53,666, 53,688, 53,650, 53,831, 53,832, is unique in the table. This attribute alone can uniquely identify each student. Login, upon reviewing the login values, Dave at CS, Jones at CS, Smith at EE, Smith at Math, Madayan at Music, Goldu at Music, each login is unique in the given instance. Login can also serve as a candidate key for this specific instance. Conclusion for 5B, based on this instance being legal, meaning it doesn't violate any key constraints implied by the instance. SID and login are examples of attributes that can be deduced as candidate keys because each value in their respective columns is unique across all tuples. B. Web and mobile programming, 50 marks. iWeb programming, 25 marks. Question 1. What are the advantages/disadvantages of various style methods? The primary style methods for web programming are inline styles, internal, embedded, styles, and external styles. 1. Inline styles. Definition: CSS rules applied directly to an HTML element using the style attribute. Advantages: highest specificity, overriding other styles. Useful for quick, one-off style adjustments on a single element. Advantages: poor maintainability, styles are scattered within HTML, making changes difficult and time-consuming. Lack of reusability, styles cannot be reused across multiple elements or pages. Increased HTML file size, clutters HTML, making it harder to read and parse. Violates separation of concerns, mixes content, HTML, with presentation, CSS. 2. Internal, embedded, styles. Definition: CSS rules placed within a style tag in the head section of an HTML document. Advantages: styles are centralized for a single page, making it easier to manage page-specific designs. HTTP request is needed to fetch the style sheet, which can slightly improve initial page load for very small pages. Disadvantages: lack of reusability, styles cannot be reused across multiple HTML pages. Versus HTML file size, the CSS code is embedded in every HTML document, leading to larger file sizes if multiple pages use similar styles. Limited maintainability for large sites, changes to common styles require editing every page. External styles. Definition: CSS rules stored in a separate .css file and linked to HTML documents using the link tag in the head section. Advantages: excellent maintainability, changes to a single CSS file affect all linked HTML pages, simplifying updates. High reusability, styles can be consistently applied across an entire website, promoting a uniform look and feel. Faster page load. After initial visit, the CSS file is cached by the browser after the first download, reducing subsequent load times for other pages on the site. Clear separation of concerns, keeps HTML, structure, and CSS, presentation, separate, improving code organization and readability. Disadvantages: initial page load delay, requires an extra HTTP request to fetch the CSS file on the first visit, which might cause a brief flash of unstyled content, FOUC, on slow connections. Relative path issues, requires careful management of file paths. Question 2, lists some necessities of using HTML forms. 5 marks, answer. HTML forms are essential for user input collection. They are the primary means for users to input data into a web application, such as text, numbers, dates, choices, files, etc. Data submission to servers, forms package user entered data and send it to a web server for processing, storage, or interaction with backend logic. 3. Interactive web applications. They enable dynamic and interactive web experiences, allowing users to search, filter, register, log in, make purchases, comment, and more. 4. Creating user accounts/profiles. Registration and profile update forms are fundamental for managing user identities on websites. 5. Feedback and communication. Contact forms, surveys, and comment sections facilitate communication between users and website owners. 6. E-commerce transactions. Shopping carts, checkout forms, and payment forms are crucial for online sales. 7. Search functionality. Search bars, which are forms, allow users to query content within a website or external search engines. Question 3. How do I create frames? What is a frame set? 5 marks. Answer. How to create frames. In older HTML versions, HTML 4.01 and XHTML 1.0 frame set, frames were created using the frame set and frame tags. The frame set tag replaced the body tag and defined the layout of the frames, how the browser window is divided into multiple, independently scrollable regions. The frame tag specified the content, HTML document, to be displayed in each frame. Example, HTML 4.01. HTML. Doc type HTML public //w3c//dtd HTML 4.01 frameset //n http://www.w3.org/tr/html4/frames/et.dtd. HTML. Head. Title my framed page /title/head frame set calls equals 25% 75% frame src equals nav html name equals left frame frame src equals main.html name equals right frame no frames. Body. P. Our browser does not support frames. /p. /body. /no frames /frameset /html. Modern approach, HTML5 frame sets are deprecated in HTML5 due to accessibility, usability, and SEO issues. Embed content from another HTML document within a web page is using the iframe, inline frame, tag. Example, HTML5. HTML. Doc type HTML. HTML lang equals n. Head. Meta char set equals UTF-8 title modern frame example /title /head body h1 welcome to my page. /h1. Here's some embedded content, /p iframe src equals another underscore page.html width equals 600 height equals 400 title equals embedded content. P. Our browser does not support iframes. /p. /iframe. P more content after the embedded frame. /p. /body. /html. What is a frame set? A frame set is an HTML, specifically HTML 4.01 frame set and XHTML 1.0 frame set, tag that defines a collection of frames or sub-windows in the browser window. It specifies how the window is divided into rows and columns, and each division holds a separate HTML document loaded into a frame tag. A document containing a frame set tag replaces the body tag, meaning it defines the entire layout of the page rather than just its content. Question 4. What are the form elements that support media content in HTML5? 5 marks. Answer. HTML5 forms primarily focus on gathering user input using text fields, checkboxes, radio buttons, etc. They do not inherently have specific form elements for displaying media content like videos or audio directly as part of the form's input structure. Media content, video, audio, images, is typically displayed using other HTML5 elements outside the direct form tag, even if they are related to the form's context, example displaying a user's profile picture. However, if the question implies form-related functionality that interacts with or handles media, these are the relevant aspects. 1. Input type equals file. This is the most direct form element for handling media content. It allows users to select one or more files, which can be media files like images, audio, video, from their local system to be uploaded to a server. Example, input type equals file accept equals image slash, video slash, audio slash asterisk multiple. Other HTML5 elements like video, audio, and img are used to display media. They are generally not considered form elements themselves. They can be placed within a form for layout purposes, but they don't capture user input for the media content in the same way an input element does. Therefore, the primary form element that supports media content, specifically for user input, is input type equals file. Question 5. How can page loading time be reduced? 5 marks. Answer. Reducing page loading time is crucial for user experience, SEO, and conversion rates. Here are several ways. 1. Optimize images. Compress images. Use tools to reduce file size without significant loss of quality. Use appropriate formats. Use JPEGs for photos, PNGs for graphics with transparency, and SVGs for vector graphics. Lazy loading. Load images only when they enter the viewport. Responsive images. Serve different image sizes based on the user's device and screen resolution. 2. Minify CSS, JavaScript, and HTML. Remove unnecessary characters, witty space. Comments from code files to reduce their size. 3. Compress files. Xip/btly enable server-side compression, like Xip or btly, to compress text-based files, HTML, CSS, JS, before sending them to the browser. Leverage browser caching. Set up HTTP caching headers, cache control, expires, 2. Instruct browsers to store static assets, CSS, JS, images, locally, so they don't need to be re-downloaded on subsequent visits. 5. Reduce HTTP requests. Combine CSS and JavaScript files, reduce the number of separate files the browser needs to download. CSS sprites. Combine multiple small images into a single larger image to reduce image requests. Inline critical CSS/JS. For very small critical styles or scripts needed for the initial render, embed them directly in the HTML to avoid an extra request. 6. Optimize JavaScript delivery. Defer non-critical JavaScript. Use defer attribute for scripts that don't need to run immediately. Asynchronous JavaScript. Use async attribute for scripts that can be loaded independently. Place JavaScript at the end of body. Prevents JavaScript parsing from blocking HTML rendering. 7. Use a content delivery network, CDN. Distribute static assets across multiple servers. Globally. Users download assets from the server geographically closest to them, reducing latency. 8. Prioritize above-the-fold content. Load and render content visible in the initial viewport first, giving the perception of faster loading. 9. Server-side optimization. Fast server response times. optimize backend code and database queries. Keep alive connections, enable persistent HTTP connections to reduce overhead. 10. Font optimization. Host fonts locally or pre-connect to font providers. Use font display, swap to prevent text from being invisible during font loading. 2. Mobile programming, 25 marks. Question 1. What is the Android Google SDK? 5 marks. Answer. The Android Google SDK, Software Development Kit, is a comprehensive set of development tools used by developers to write applications for the Android platform. It provides everything needed to build, test, and debug Android apps. Key components and functionalities of the Android SDK include 1. API libraries, pre-built code libraries for interacting with core Android functionalities. UI components, data storage, network access, device sensors, camera, GPS. 2. Development tools. Android Studio, the official integrated development environment, IDE, for Android development. Build tools, example Gradle, for compiling, packaging, and signing Android applications. Emulator, a virtual device that simulates Android devices, phones, tablets, wearables, TVs, on a computer, allowing developers to test apps without a physical device. Debugging tools, example Android Debug Bridge, ADB, for inspecting app behavior, logging, and troubleshooting. 3. Documentation, extensive documentation on Android APIs, development guides, and best practices. 4. Samples and templates, code examples and project templates to help developers get started quickly. 5. Platform tools, components like ADB, Android Debug Bridge, Opt, Android Asset. Packaging tool, and DX, Dalvik executable converter, that are crucial for interacting with devices and building APKs. In essence, the Android SDK is the foundation that enables developers to create applications that run on Android-powered devices. Question 2. Describe the Android framework. 5 marks. Answer. The Android framework is a set of APIs, application programming interfaces, and services that form the foundation for building Android applications. It sits above the Linux kernel and provides developers with access to the core features and hardware capabilities of an Android device in a standardized way. Key aspects and components of the Android framework include 1. Activity Manager, manages the life cycle of applications activities. 2. Window Manager, manages the drawing and layering of windows on the screen. 3. Content Providers, enable applications to share data with other applications, example contacts, calendar. 4. View System, provides a rich set of pre-built UI components, buttons, text views. Layouts, that developers can use to construct user interfaces. 5. Resource Manager, manages application resources, strings, images, layouts, colors, that are separate from the application's code. 6. Location Manager, provides services for determining device location, GPS, Wi-Fi cellular. 7. Notification Manager, allows applications to send notifications to the user. 8. Package Manager, manages installed application packages. 9. Telephony Manager, provides information about the device's telephony services, example phone calls, network state. 10. System Services, a collection of core services, example power management, connectivity alarm, that run in the background and are accessible to applications. In essence, the Android framework provides the building blocks and rules for how Android applications interact with the operating system and device hardware, allowing developers to focus on application logic rather than low-level system interactions. Question 3. What is the importance of having an emulator within the Android environment? 5 marks. Answer. The importance of having an emulator within the Android development environment is significant for several reasons. 1. Cost effectiveness. It eliminates the need for developers to own a wide range of physical Android devices, different screen sizes, Android versions, hardware capabilities, for testing, saving considerable expense. 2. Accessibility and convenience. Developers can immediately test their applications without needing to physically connect a device, making the development workflow faster and more convenient, especially for remote work. 3. Testing various configurations. Emulators allow developers to simulate different Android versions, screen resolutions, hardware features, example GPS, camera, battery status, network speeds, and even sensor data, enabling comprehensive testing across diverse device scenarios. 4. Debugging. Emulators integrate well with debugging tools, providing a controlled environment to step through code, inspect variables, and monitor system logs, which is crucial for identifying and fixing bugs. 5. Reproducing bugs. Specific device configurations or scenarios that are hard to replicate on a physical device can often be set up and consistently reproduced on an emulator, aiding in bug isolation. 6. Development without physical devices. For new developers or those without immediate access to physical devices, emulators provide an immediate entry point into Android development. 7. Performance profiling. To some extent, while not as accurate as physical devices, emulators can offer insights into an app's performance and resource usage. While physical device testing is still necessary for final verification, especially for subtle hardware interactions and real-world performance, emulators are an indispensable tool for the majority of the development and testing cycle. Question 4. Enumerate the 3 key loops when monitoring an activity. 5 marks. Answer. When monitoring an Android activity's life cycle, the 3 key loops or nested sets of callbacks are 1. The entire lifetime, full loop. This loop occurs between the first call to onCreate, and the single call to onDestroy. An activity goes through this entire life cycle when it is first launched until it is finally terminated and released from memory. Callbacks involved: onCreate, onStart, onResume, onPause, onStop, onDestroy. 2. The visible lifetime, visibility loop. This loop occurs between the call to onStart and the corresponding call to onStop. During this time, the activity is visible to the user, though it might not be in the foreground or interactive. An activity can go through this loop multiple times as the user navigates between activities. Callbacks involve onPause, onStop. 3. The foreground lifetime, foreground loop. This loop occurs between the call to onResume and the corresponding call to onPause. During this period, the activity is in the foreground and actively interacting with the user. An activity frequently transitions through this loop as users switch between apps or screens. Callbacks involved: onResume, onPause. Question 5. Explain the proper way of setting up an Android-powered device for application development. 5 marks. Answer. Setting up an Android-powered device for application development primarily involves enabling developer options and USB debugging. Here's the proper way. 1. Enable developer options on the device. Go to Settings on your Android device. Scroll down and tap on About Phone, or About Tablet, About Device, etc. Find Build Number. Tap Build Number rapidly 7 times. After a few taps, you'll see a toast message counting down. You are now X steps away from being a developer. Keep tapping until you see you are now a developer. 2. Enable USB debugging. Go back to Settings. Now, you should see a new option, Developer Options. Tap on it. Its location might vary slightly. it's often under System or directly in Settings depending on Android version. Inside Developer Options, find and enable USB debugging. You may receive a warning message, accept it. 3. Connect the device to your computer. Using a USB cable, connect your Android device to your development machine, where Android Studio is installed. 4. Authorize USB debugging, first time. The first time you connect, a dialog box might appear on your Android device asking, allow USB debugging. Check Always Allow from this computer, highly recommended for convenience, and then tap OK or Allow. 5. Verify device connection in Android Studio. Open Android Studio. In the toolbar, look for the Target Device drop-down, usually next to the Run/Debug buttons. Your connected device should now appear in this list. If it does, you're successfully set up. If not, try changing the USB connection mode on your device. Pull down the notification shade, tap the USB connection notification, and select File Transfer or PTP if available, then try No Data Transfer if those don't work. Installing the correct USB drivers for your device on your computer, often handled automatically by Android Studio or Windows Update, but sometimes manual installation is needed. Restarting Android Studio and/or your device. Once these steps are completed, you can select your physical device in Android Studio's Run configuration and deploy/debug your applications directly on it.